So very good evening, guys. I'm audible to you. So very good evening. I think I'm visible. Is my voice is clear for you? Can anyone respond in chat box? So very good evening to all. Thank you for joining. Second day of our masterclass on advanced VLSI design and verification. So very good evening to all. Good evening, Subulakshmi. So Chaudhary, good evening. Check the audio. So let me check the audio. So now it's clear. I'm audible to you. Is my voice is clear? Okay. Thank you for your response, Lucky, Satya, Abhishek. So thank you for your response. So today we are gonna see computer architecture. So what is the purpose of computer architecture? So let's see in this session. So thank you for joining. So thank you for your interest on my master class. So very good evening to all. It's clear. Thank you. This is Annamalai. So good evening, Annamalai. So thank you for your interest. So why? Because of I'm thanking you means most of people are not interested to learn the VLSI. So you guys are interested. It is very special to me. Thank you for your response. So okay. So I think we will start now. So yesterday we seen some content about chip making. So how the chips are made, what is actually inside the chip. So we will see some recap. So recap means I will ask some questions. You can respond in chat box. So my first question is what is actually inside the chip? Okay. Can anyone respond your answers in chat box? So what is actually inside the chip? So VLSI engineers are building something. So what is that particular thing? So I want to name that device. So what is actually inside our chip? So you can respond in chat box. Yeah, I got some response from your side, Jayaprakash. You are telling correct transistors, correct answer. So correct transistors. So as a VLSI engineers, we are building the n number of transistor in single chip. Okay. So let me show you something about chip related things. So this is a chip looks like. So after the manufacturing, the chip layout like this only. So you can see here something catchy, ARM Cortex A9 CPU cores, video processing, video decoder processing, and then image signal processor, audio processor, dual display, HDMI, NAND flash memory, IO graphics processors. So this is a kind of SoC. So yesterday I said no. So we having the variety of chips like SoC chip, microcontroller, microprocessor, ASIC chips, FPGA chips. We having the variety of chips. So this is a kind of SoC, system on chip. So this is a chip we having in our mobile phones. Okay, our mobile phones is based on the chip kind of like a SoC only. So inside the chip we having all the components like a CPU. So these are the CPU cores, ARM Cortex. So ARM Cortex is like a architecture. So ARM Cortex CPU cores, and then GPU cores, graphics processor GPU cores, and then cache is kind of memory, and then A7 CPU cores, additional processor CPU cores, and then we having a lot of peripherals like we having a lot of components like a USB interface, HDMI interface, NAND flash memory, dual display, audio processor, image signal processing. So these all things are built by the VLSI engineer as a physical chip. So today we are gonna see the computer architecture. So we already having the chip. Okay, it is a physical hardware thing. So we need to control that. So if you are using the computer means what is the main usage of computer means we are controlling the transistor. So this is a main thing of computer working. So we are just controlling the hardware by using something called my computer architecture. So we are having some layers. So hardware is a base layer, and then in the mid of we having OS kind of thing, like it's like a computer architecture itself, and then we having a software like application. So that particular application, by using that we can control the hardware. For example, if you having the mobile phones, okay, everyone having mobile phones. If you want to open the camera, so if you want to open the camera means you just have to click the camera app application logo kind of thing, and then it will automatically open the hardware. So it will automatically open the hardware, it will use the hardware, it will capture the, it will take the input from the camera, and then it will display the output by using the display monitor. So actually by it will flow from software, it will start from software part, and then it will end from hardware part, and then it will take the results from the hardware, and then it will given to the software. So it's like a flow kind of software to hardware. So in between that there is a one thing, that is a computer architecture. Okay, our OS, our Android are based are runs based on the computer architecture only. So today we will see only brief thing about computer architecture. We can't see the elaborate things about computer architecture. Why? Because means it will take more time to see the all the information about computer architecture. Okay, clear now? Before that, I want to share something about internship program. So I'm so happy a lot of people are purchased our internship program. So I will say some names of who buy that internship program. So namely Subha, Saravanan, Akram. So there are a lot of peoples there, like Jado. So some of them north side. So I'm so happy from your response, your purchasing our internship program. So thank you for that. So let's see this. Let's get into session. Okay. Good evening. Combinational and sequential circuits designed by transistor. Yeah, correct answer. So Narayanamurthy, you are telling the accurate answer. So we are building transistor. They will do performance based on the circuits like combinational circuits and then sequence circuits. Okay. So speak louder. Just a minute. So I think it's now clear. So let's get into session. So before that, I have one question. This is the question. Without this device, your computer can never boot. You can guess which one is it. So on it is. It's like there is one device. That device must be on. Then only your computer will boot. Without that particular device, your computer won't boot, won't execute, won't work. So I want to know what is the particular device name. So this is comes under the electronic device only, So okay, so I want to answer some. So I want some guesses from your side. So what is that particular device? It must be on. Then only you can you will boot your OS. You will boot your computers. BIOS. So BIOS is one kind of bootloader only. If you want to activate the bootloader, you want one electric pulse or one electric device. That device must be on. Then only you can OS. So OS also, if you want to boot your OS means you need some input from electronic device. I want the name of particular electronic device. So without this device, your computer can never boot. Can you guess which one it is? Processor, CPU, hard disk. So there are it's correct only, but all the like a CPU, OS, RAM. If you want to functional all these things, you need one input from electric device. So I want to name. You can guess anything. So it's based around. So that is a main thing. So we are using the high speed chips. We are using high speed computing operations. We are achieving that only. So we are using the chips at very high speed. So that speed also based on that particular device itself. So for speed execution, for instruction passing, all the like whatever you are using computer means, without that device computer will never work. So bootloader is correct, but that particular bootloader needs some input from that like a one CMOS clock. Yeah, I think Chowdhury is telling correctly, CMOS clock. So not a CMOS clock, we need clock pulses. Okay, based on the clock pulses only our computer will boot. It will work, it will boot our OS. The like you're telling like a BIOS bootloader, it will boot our OS based on the clock pulses. So clock pulses, who will give the clock pulses? So clock pulses will given by the crystal. So crystal is a main device. That device will give the clock pulses. Okay, based on the clock pulses only, our bootloader, our OS will boot, and then it will boot our OS. We can use the Windows or any OS. So crystal is a correct answer. So crystal is a main thing. So it is important one device for all electronic devices. Without crystal, you can't do anything. Why? Because of it, in the crystal we are getting the clock pulses. So we are doing some instruction. If you are doing the addition operation in the computer, means for that reason, for that purpose also we need crystals. Means we need clock pulses. So each and every clock pulse is very important. Based on the clock pulses only, the computer will execute the instructions. They will process some things, whatever we are given to the computers. Okay, crystal oscillator. Yeah, VK is telling correctly. Crystal oscillator is very correct answer. So I think it's clear for you. Crystal is very important. So you can also notice that if you are buying the new mobile phones, they are telling 4.3 gigahertz clock speed. So means that particular device are running with 4.3 gigahertz of clock. Okay. So I will come later about clock related things. It's a very huge topic. It is also important topic. Okay, of VLS engineer. If you are a VLS engineer, you must know what is a clock pulses, what is a neck edge passage, and what is a one clock cycle, ratal kind of things. You must know that. So I will tell you in upcoming sessions. So okay, so sir, what is mean by crystal oscillator? So it is on device. It will give the clock pulses. So clock frequencies, telling like a 50 megahertz, 60 megahertz of clock. That all things are given by the crystal device. It is one device. Okay, so let's get into session computer architecture. So this is our topic. So this is a simple thing like a CPU. So functionalities of computer architectures. We know that we having the CPU. Inside the CPU, we having the control unit, arithmetic logic unit, memory unit, and then input and output devices. For example, if you take an example as your system, it having CPUs, and then input devices called mouse, keyboard, output devices are a monitor, like a printer, any kind of things. So it having some input devices and output devices, but in between it having some blocks like a control unit, arithmetic logic unit, memory unit. So what is the purpose of these units? So we will see one by one what is the purpose of these units in CPU. Okay, this is a very important thing. And then we will move into RISC-V architecture. So it's not like a control unit. So control unit is not like a simple thing. It will follow some architecture, kind of form architecture, RISC-V architecture, x86 from Intel. So there is a lot of architecture is in market. So each and every processor CPU cores are built based on the computer architectures. As you are a VLSI engineer, you are making chip, and then you are making some CPU cores. So if you are making the CPU cores, means you must aware of the computer architecture. So based on the computer architecture only, you can make the CPU core inside your chip. Okay, so I will tell you one by one. So what are the usage, so what is the functionalities of CPUs, one by one. Okay, till now, do you guys any doubt? You can ask now. So till now, do you guys any doubt? You can ask in chat box. So we seen like a front and back end yesterday of chip making, and then today we seen like a basic thing of crystal clock pulses. So I think a RAM processor. So I think we'll move to the next. So just a minute. So this is we'll see the fundamentals of computer architecture only today. Okay, and then we will see some overview of RISC-V architecture. In the end of the session, we will see some overview of RISC-V architecture. Okay, so and then first of all, what is computer architecture? Already said no. It will do some control. It will do some control operation, arithmetic operation, memory operation. So this is a basic things of computer architecture. Okay, computer architecture dedicates every aspect of computer functioning. So functioning means it will get the input from user and it will do something based on our instruction. It will execute, it will do something based on our instruction, and then it will give output. So this is the working of computer. The CPU core will get the input from user. User are mostly given like instructions only. User are giving only instructions. CPU will receiving the instruction and then it will do the expective things regarding the instruction, and then it will give the output to user by using the monitor or any other peripheral devices or any other interfaces. So this is a basic thing. CPU having transistor, user just controlling the transistor, not directly. So you can't directly control the transistor. So you have to use some medium. That medium is called computer architecture. Okay. So user can give the instruction to CPU. CPU will receive the instruction. They will perform some instruction operations, and then they will make the results, and then the CPU will give the output to user. Okay. This is the functionalities of CPU. So let's check. Let's see what are the components of CPU. Central processing units, memory unit, and then input and output devices, and then buses. So here we already know that what is memory. So memory means, so CPU is there. So if you given like you want to give the instruction to CPU, you can't directly give the instruction to CPU. Why? Because of you have to store one place. If I have 4 instructions. So if I want to execute all 4 instructions, okay, but you can't directly execute. So you can't directly given to CPU. You must have to store one place, some memory. It's called register, or we can say like a memory, or instruction register, instruction memory. From that memory, CPU take the instruction and then it will execute. In the execute means it will do the arithmetic logic operations, and then it will give the output to user. And then CPU also can't give the output directly to user. So CPU will store the result, but one kind of in memory. From that memory, user can get the data. So memory is a main thing. So you can't directly like a CPU by using the CPU can't get the data from user directly. The CPU will get the data from memory, and then it will do computing operation, and then it will store the output from to the one memory, and then from the memory itself we can get the data, we can get the results. So this is a basic working of CPU. Okay. So and then these are the main components: arithmetic logic unit, control unit, registers. So let's see one by one. So arithmetic logic units, it will do the perform operations. Perform operation means nothing but addition, multiplication, subtraction, AND operation, OR operation, NOT operation, XOR operation. These all things comes under the ALU, arithmetic logic unit. Okay. So I have some query here. It's like a transistor requires transmitting data 1 bus, 2 bus 3, but etc. in a bus. So it's bus means I will tell you one by one what is a bus. Okay, I will tell you one by one what is a bus. Don't confusing. So and then coming to the control unit. So control unit means it will control the instruction and datas. So CPU will do the CPU inside the CPU it having the ALU block. ALU block will do only the addition, some arithmetic operation only. So who will give the instruction for ALU? That on that time the control unit will take the responsibilities. So it will control all the instructions and datas. So if you want to do the addition operation means that additional keyword, that additional instruction which is given to arithmetic logic unit, okay, that is given by the control unit only. And then registers. So the register means it will store the data temporarily, temporary storage. We can store the current data, and then we can access. It will mostly used for fastest access. Why? Because of CPU doing lot of operations, lot of instructions. It will continuously fetching the data from memory. It will do operation, and then it will store to the memory. So this is a basic work of CPU. It will the control unit will give the instruction to arithmetic logic unit. The arithmetic logic unit will do operations like based on our instruction it will do operations. It may be addition, it may be subtraction, it may be under operation, it may be XOR operation. After that after the execution it will give the data, and then that data is stored in register only. Okay, from that register only we can get the data. So this is a basic things: register, control unit, and arithmetic logic unit. Okay, and then we'll move to the memory system. So we having a lot of memories. We having a lot of memories like RAM memory, ROM memory, flash memory, and then EPROM memory, EPROM. So we having a lot of memories, but we can divide into two types. One is volatile, another one is a non-volatile. So volatile is kind of temporary memory. Okay, like for example RAM. So RAM comes under the volatile memory. You can see you can see here also. RAM is a kind of volatile memory. It means it's a temporary memory. It can store the data temporarily itself. It can store the data only temporarily. It can't store permanent. So if you want to store the permanent data, means you have to use non-volatile memory. Non-volatile memory is nothing but ROM, read-only memory. And then these are the primary memories for computer architecture. Secondary memory is our SSD, HDD, and then optical disk. So these are our internal storage. This is our main storage, like not like a main storage. It's like a secondary memory. So we can store the data. We can use the data based on our instruction only. So this is there are two memory systems: primary and secondary. Primary means RAM and ROM. Secondary means SSD, and then disk, hard disk kind of things. The hard disk all comes under the secondary memory. Why we are calling that secondary memory means the processor won't need the data very much from the secondary memory. The processor will need the data from primary memory only. Why? Because of we are storing the instruction data only in the primary memory, not in secondary memory. Okay, inside the CPU there is a memory is called only primary memory only. Our registers are comes under the primary memory itself. Okay, it's a kind of temporary memory inside the chip. So what about a cache memory? So cache memory. So if you see this, if this is picture, I will show you. I will explain what is the cache. So you can see here. Here we having the CPU core, one ARM Cortex A9 CPU core. So this is one CPU core. So each and every CPU core uses the cache memory. So there is a kind of level 1 cache, level 2 cache, level 3 cache. So cache memory is nothing but if you are using one address, like a memory means it is fully based on the address only. If you are using address simultaneously, repeatedly, so you are using one address repeatedly, that address will store in cache memory. Why? Because of if you are using that address particular randomly means repeatedly means it will store in cache memory. Why? Because of the computer, that architecture will defines like that only. That particular address are used by user mostly. So we have to store that address in the cache memory. So why? Because of why we have to store in cache memory means you can see here the cache is very near to CPU. So by the CPU can easily access the cache memory. Why? Because of internal storage it is so far to CPU. Why? Because internal storage means it is outside of the chip, and also RAM and ROM also it is in another block of chip. But you can see here cache and CPU core are just in very close. So very just like a very close in the architecture, in the chip architecture. So based on the chip, based on the CPU, it can easily access the cache memory data. That's why we are using cache. Inside the cache we are storing the repeatedly using addresses. Okay, not like any other data. It will store only repeatedly using addresses only. Okay. So and then I think it's clear for you cache. What about cache memory from Satya? And then if you play a game, then the processor needs secondary storage. Please explain. So if you are playing the game, we don't need mostly the CPU won't use the secondary memory. Why? Because of mostly the games are run by the GPU. GPU is process of executing parallelly. Okay, CPU will execute instructions serially one by one, but GPU execute instruction parallelly. So at a time it will do a number of tasks. So that GPU needs some instruction, CPU needs some instruction. That instruction are stored in registers. So register is a primary memory. So mostly gaming are fully based on the primary memory only. Okay, that graphical files, that background files are stored in secondary memory, but by CPU will fetch the data from the secondary storage, and then it will store the instructions in these registers. So CPU will fetch the data, main data from the secondary storage, secondary memory, and then it will make some instruction, and then that particular instruction are stored in register only. So register is a primary memory. Okay, so for fast computing we have to use CPU are using only the primary memory only. Like a primary memory means registers. Okay, I think it's clear for you. So does cache memory is a ROM? So no, cache memory is a ROM. So ROM means read only memory. You can't overwrite the ROM. So it's like a flash memory. It's like a flash kind of thing. It's like a memory. It will updating the addresses itself. It's like a ROM only, but we can overwrite the ROM like a EPROM. So do you know the EPROM, electrically erasable programmable read only memory? It comes under the that kind of thing. So cache is one kind of memory. It's not same for ROM and RAM. It's like it's one memory, cache memory. So does cache memory takes internal storage? No. It is a separate memory. It won't take internal storage. So internal storage is nothing but our SSD hard disk is internal storage. So in the internal storage we are storing some base files which is used for CPU. Okay, the CPU will get the data instruction from the some data from the base files in the hard disk, and then the CPU will make some instruction to do some our operations. So it's like a flow of there is a one huge memory here, and that memory is called secondary memory, and then there is another memory is called primary memory. It's a small memory. In the primary memory we can store only instructions only. We can't store the data. So you can't store the huge data in primary memory. You can store only instructions and then functionalities of your user input. Okay, inside the cache memory they have data and buses. So inside the cache memory, it having only the addresses for instruction. So in the registers we are storing instructions. Okay, we are storing instruction, and then in the cache memory we are storing addresses. Addresses means we are storing instruction in one memory, so it having some addresses. In the cache memory we are storing the particular instruction address. It's like in the cache memory we are storing addresses for instruction. So like instruction memory addresses, like register addresses. We are mostly storing that instruction in registers. So in the cache memory we are storing the repeatedly using registers. So inside the register memory it having the some instructions. It may be AND operation, OR operation, and NOT operation, lot of things like a load and store. If you read the ARM architecture or RISC-V architecture things, you will get some understanding about the register instructions. So this is a very huge topic, memory hierarchy, and then memory addressing, and then instruction fetching, decoding is a huge topic. It will take more time, so we will take some in some other classes. So we will continue from the memory system. So we have completed the memory system, and then we'll move into the IO devices and buses. So IO devices means we already said keyboard, mouses are called IO devices. And then buses. So coming to the point, buses means, just a minute. sorry for inconvenience, I have some battery issue. Okay, so we seen some IO devices. Like IO devices means nothing but uh, input and output devices. We are mostly using input devices for computer is keyboard, mouses, and the output device is monitor, printer. And then coming to the buses, so we are using some. I'm audible. Can anyone respond in chat box? Is my voice is clear? So what is difference? What is the basic difference between HDD, SSD? So the main difference is speed. So SSD is a more speed. It comes under the RAM kind of thing, RAM memory. So it will execute the instruction. It will data transfer is very high speed. So this is a basic thing. Difference between the SSD and HDD. SSD is a very high speed. So our laptops are having SSD only. So and then data buses, address buses, control buses. So here I will show some on architecture. It having some buses like a data bus, address bus, and control bus. Mostly in data bus, it will transfer the data from one block to another block. In address buses, it will send the addresses like a register addresses kind of thing. And then control bus means it will useful for instruction transferring. Okay, computer architecture having three buses: data bus, address bus, and then control bus. Data bus is useful for transmitting the actual data, and then address bus is useful for sending and transmitting the address of registers. Okay, means the register means in the register we are storing instruction. So in the address bus, we can store in the CPU can store the address for the address of that particular registers. Okay, register memory. So and then coming to control bus. So control bus is in the control bus, CPU can store CPU can transmit the instructions. Okay, and operation. I will show the instruction how they look like. So and then we in 1960s or 70s, I think so. So humans are first introduced the von Neumann architecture. So this is one computer architecture was firstly introduced by von Neumann. So that in this particular architecture there is some issues called why the main issue is instruction and data. So instruction and data are stored in single memory. So this is main disadvantage of the von Neumann architecture. After the long time, so we got a hardware architecture. So hardware architecture is nothing but we are currently using some architectures like a CPU architecture, like ARM architecture, RISC-V architecture, x86 architecture. So this all comes under the computer architectures. So these all architectures are based on the hardware architecture only. So hardware architecture is nothing but in the von Neumann architecture, we are storing the address and data in single memory. Here we are storing the data and instruction in separate memory. Okay, here you can see that separate memory for data and instructions. Okay, and then independent buses. So independent buses means address bus, control bus, data buses. So and then these are the advantages like concurrent bus access, reduced corruption risk, and then better performance. So and then it having some more disadvantages called like more complex architecture, high cost, more difficult. Just a minute. More difficult to program. So this is some kind of complex architecture. So and then coming to we are using two architectures currently. One is RISC and then CISC. RISC means reducer instruction set computer, and then CISC means complex instruction set computers. Okay, so there is a difference between RISC and CISC. So the name itself, it having the complex means it will the instruction set and then addressing unit and then memory unit are mostly it's in the complex kind of thing. Okay, it will do only single processing unit, and then it will do only one task at a time. It will take less memory usage, and then it will do slower execution in this CISC kind of architecture. If you are making the one chip, you will in that chip following the CISC kind of processor means architecture means it will do these kind of things only. Single processing unit, one task at a time, less memory usage, and then slower execution, complex instructions. But if you are using the reducer instruction set computer means we will do some we did some optimization in architecture from hardware architecture, and then we got some RISC kind of processor architecture. It will it will it will do fast execution, and also uh, fast execution means it will following the pipelining and parallelism. So I will tell you one by one what is pipelining and what is parallelism. So RISC kind of processor will do the larger, it having the larger registers, okay, and then frequently used variables in processor, faster operation, simple instruction, pipelining friendly. So we are using mostly RISC kind of processor only, okay. We are mostly using RISC kind of processors. So we are following the RISC kind of architecture only nowadays. So each and every computer architecture having some registers list. So I will show you one by one. So in upcoming slides. So each and every, so you can see here RISC and CISC processor having some ISA. So ISA means nothing but instruction set architecture. So based on this ISA only, CPU works. How we can say means, so in your Python code or any SystemVerilog code, you are writing a equal to 5 plus 1. So you are doing the addition operation, it having some operates, and then we have to store the 5 plus 1 6 in the memory of A location. So A is a one register, we have to store the 5 plus 1 6 in the A register. So these things are controlled by the ISA in computer architecture. It means instruction set architecture. So let's it is a very big topic. So if you are a VLSI engineer, if you are embedded engineer, you must know this ISA things, like each and every chips, like ARM chip, ARM based ARM computer architecture, and then RISC-V based architecture are following, are they having some separate ISA instruction list, okay. So we'll see only brief intro about ISA only, okay. So you can see here it determines, ISA determines the software compatibility and performance. So ISA is the main thing controlling the hardware, okay. So and then this is a bridge between the hardware and software. I already said no, ISA and computer architecture is a bridge between the hardware and the software. So and then it having the three kinds of ISA: stock based ISA, accumulator based ISA, and then register based ISA. So stock based, it follows the last in first stored structure. So we are mostly using this thing like a register based ISA. So I already said no, we are storing the instruction, sorry, not we are, CPU storing instruction in memory. So CPU are storing instruction somewhere in register memory, so we are following that only. So this ISA is we are following currently. So register based ISA, multiple registers. So multiple register means it having some it having some lot of memory location. It's like a registers, we can store the data, we can store the instruction. So and then most common today, so this is the most common today, register based ISA. So and then pipelining and then parallelism. So before going to that, I will show you some architectural. So without seeing that, you can't understand. So what is pipelining, what is the instruction, so what is the pipelining and parallelism, you can't understand. So I will show you the architecture. So before that, I have some query here. So we have seen register are designed using the D flip-flop. Do we use the same technology in today design too? Yeah. So correct, from Neha Kapil. We are D flip-flop will do the storing. So it will store the 1-bit data for 1 clock cycle. Okay. D flip-flops are mostly used for storage purpose. So register means while writing the Verilog code, HTL code, if you want to make a memory means you have to use the flip-flops only. Okay. So here I am telling the register is same as the D flip-flop only. So I am telling like a base eye level site. So eye level, so Verilog and design. So RTL code it's like a low level. So it's like a hardware level. But in our registers means is eye level. So both register and D flip-flop are same only. So if you see the register in upside, and the base of the register is a D flip-flop only. So we are going to write the RTL code or design code for the registers. So I'm telling like this buses, like I'm telling like registers, and then architecture. We have to write the Verilog code for this architecture. So this is the main work of design engineer. Okay, I'm telling this is not like architecture. So by using this architecture, we are writing the RTL code, and then by based on the RTL code, we are converting into gates, and then we are converting into transistor, and we are building into chip. So this is a flow, basic flow. So both register and the T flip-flop are same only. Okay. So kindly share the attendance link day 1. So you will get. So and then we'll move to the pipelining in person. So I want to show something. So in this is a company called Shakti processor. So Shakti processor is nothing but in IIT. So you guys know about IIT Madras. IIT Madras with Shakti, they build processor. So it is the India's first processor, which is made by the Indian own product of chip. So they are building some kind of SoC chip, and then processor chip, and then controller chip. So I will show you something. They are using the RISC-V architecture. Why? Because of ARM architecture and the x86 architecture are if you want to use, means you have to pay for that to buy the patent. But RISC-V is a open source, like a Linux is a open source. You can also use the RISC-V architecture. You can also use RISC-V architecture ISA. Based on that ISA, you can make the chip. You can make the chip, and then you can make your own OS, and then you can publish kind of thing. So OS for OS purpose also, that architecture is very important. So if you are using RISC-V architecture, you want to operate the Windows 11 OS in RISC-V, means you have to optimize the architecture based on the Windows OS. So there is some things like architecture is very base to boot the OS, to run the OS. So we have to make the architectural design based on that your OS only. So this is one company in Chennai, Shakti processor. They are collaborative with IIT. They are making some processors, C-class processor, the controllers, SoCs. So I will show you the architectural. So this is a microarchitecture for their processor, their chip. So their CPU are look like this only. Inside the chip, they are following this processor only. You can see here instruction catchy, fetch, PC means program counter, and then pipeline buffer, and then decode and operand fetch, and then execution, memory accessing, and then write back unit. Okay. Here you can see the data cache. So here it's like a memory only. So data cache and the instruction cache are memory only. Here in this cache memory, the CPU will store the instruction of what are the instruction we are performing, that are stored in this instruction cache only. Datas are stored in this cache memory. So instruction means nothing but you are doing a equal to 5 plus 1. So addition is the instruction. Okay, that are stored in this instruction cache, and then datas operand means 5 is one data, and then 1 is another data, that are stored in data cache memory. So and then here it will fetch the data. Here we are doing the fetch data. Fetch means getting the information, and then here you can see the program counter generation. Here is the need for clock. So here it will count the program. So here it will count the instruction counts. So how many instructions are done. So this is a basic flow. So it will fetch the instruction, and then it will given to the decoder and operand fetch, and then it will fetch the operand from the datas, and then it will given to the execution. Execution means nothing but ALU, arithmetic logic unit. So and then it will send to the memory access unit. So it will after that it will store the data, and then it will send to the write back unit. So write back means output unit. So there is a lot of operations in the computer architecture. It will take whole day to explain. So and then you can see here some buses called AICTE buses, UART. These are the peripherals like I2C, SPI, and then PWM, and then lot of peripherals, real-time clock module, UART. So this is a CPU core. So these are the peripherals. If you want to communicate with peripherals, means you have to use buses. That is a buses, AMBA buses. We will see the AMBA protocols in the end of the master class. Okay, AXI, APP, HAP, AHP, related things. So these are a very huge topic. It will take more time to explain, but it will look like this only. It will fetch the data, and it will execute, and it will store into memory, and then we can get the data from the memory. So this is a basic flow of computer architecture. Okay. So till now, do you guys any doubt? Kindly ask in chat box. Sir, I am from embedded background. We are familiar with registers. Okay, good. And then kindly share. Okay, and then we see some basic things about computer architecture, and then I will show you another thing. So how they are execute, how the instruction looks like. So like catchy. So each and every processor core having the L1 catchy, L2 catchy, L3 catchy. So L1 means very small in size, but it is very near to CPU. And then L2 catchy is a very large in size compared to L1. It is little far from CPU. And then L3 catchy is very larger than L2, and also it is so far from CPU. So there is a lot of kind of cache memories, L1, L2, L3 cache memory. While I am getting into SOC, I will explain what is L1, L2, what is L2, what is L3. Okay. So and then cache mapping. So that has three kind of mapping: direct mapping, associative mapping, set associative mapping. So direct mapping means one-to-one mapping. Associative mapping means flexible but complex. So I will tell you one by one in upcoming classes, because it will take more time to explain. So I will show you another thing. So we'll see that till now we are seeing this only, like control unit, ALU unit, and memory unit only. Okay, this is a basic architecture I already shown you, and then we are enter into RISC-V. So before that, we'll give some difference between the high level language and assembly language. So assembly language, so we are writing the Python, SystemVerilog, C++. These are the coding languages. These are called high level languages. After the compilation, it will converted into the assembly language. Assembly language means it having only instructions. So it will look like this only. So this is a instruction. This is the assembly level language. So it will differ from architecture. So one architecture to another architecture, it will differ from. If you are using the ARM architecture, it having some assembly language code. If you are using the RISC-V, means it having some instruction, it having some assembly language code. So main thing is high level language like a Python code or C++ code, SystemVerilog code are converted into the assembly languages. It will look like this only. Okay. So here I'm going to show the difference between the high level and low level. So high level means C, Java, SystemVerilog. Low level means RISC-V architecture assembly language, and then ARM architecture assembly language, so x86 assembly language. This all comes under the assembly language. Okay. And then complex data structure. So in the high level language, we are using the structural array OOPS concept for high level computing, but in the assembly we mostly use bytes, bits, word, and registers. Word means 32 bit, byte means 8 bit. So this is the difference. So here complex controls like if else, nested if, for loop, but in assembly that are in the form of control transfer instructions, branch or jump. Okay, these are the mostly used architectures, RISC-V and ARM architectures. So and then this is an instruction set, ISA for RISC-V. So reducer instruction set computer. Fifth this V is not like a V, it is a Roman 5. It means RISC-V is a open source, they are developing continuously. In the fifth versions only they are standardized the architectural. Okay, that's why we calling as RISC-V. So pipelining, so I missed that. So pipelining means, so in the here you can see here in the one program count, it will fetch data from instruction cache, and also it will fetch data from data cache. Here we can it will store the data cache. So main difference of pipeline means it will do if you're doing one operation and the same time it will do another operation, so it's like a overlapping. So here overlapping means in the same time fetching the instruction fetching the instruction from instruction cache, and the same time the data cache also are stored in memory access unit. So in the one program count, it will do multiple operations, it will do overlapping operations. The overlapping operation is called pipelining. Okay, nice session was it. Yeah, thank you for your response, Asaf. So and then we'll continue. So these are the instruction ISAs: R type, I type, S type, B type, J type, U type. So if you want to learn ISA of RISC-V means I will post dedicated video for the RISC-V architecture. Okay, if I take means it is a very huge topic. So I will just give the overview of ISA only. So it having a lot of types: R type, I type, S type, B type, J type, U type. Okay, and then in the RISC-V ISA, so I already said no registers. So each and every, if you are using the 32-bit computer or 64-bit means that 64-bit and 32-bit is referring the width of the registers. Okay, so here you can say this is a register. In the register we are storing the instructions. This is our memory. Here also we are giving here only we are giving some main instruction in this memory, in the RAM memory, and then we are passing data from this memory to registers. So in the arithmetic logic unit will fetch the data, will fetch the instruction from the register, and then not only instruction, in the ALU will fetch the instruction and also operands and then operators. So I will show you the what is operands, opcode and operands. Okay, so here we showing the instruction and then datas. For example, A equal to 5 plus 5 means in the register we can store the instruction. Addition is a one instruction, and then we can store the datas like a 5 and 5 we can store here in the instruction in the register, and then that particular ALU will fetch the data from register, and then it will do some arithmetic operation. It will give the output for user. So this is a main thing, okay, of CPU like a computer architecture. So and then this is the instruction format. So 0 to, I already said no, this instruction having 32-bit width. So 0 to 6 means opcode, and then read or write, and then functional. So each and function 3, function 1, each and function having some separate operations. Okay, if you read the instruction list, ISA list, you can easily understand. So and then this is the address of this. RS1 is the address, RS2 is also an address. So and then function 7 is also one functionalities, it will do some operations. So I'm just showing that how the instruction looks like in the 32-bit. So this is a instruction format of 32-bit RISC-V processor architecture. So this is the main thing. So you can see here load and store. Load means we are load into register. We are store. Load means this is one register. I'm loading the whatever it we having the R0 is one register. Whatever it having the value, I'm loading to this A value. So I'm just loading and storing. This is assembly code. So main thing is we having the transistor in the chip. So transistor will work based on the zeros and ones only. Okay, so we have to convert the registers into zeros and ones. This is how that ISA converting. Okay, add. So add operation means that you can see here 0 0 0 0 means add, load means 0 1, store means 1 0, and then load means 0 1, and then this arithmetic operation, add, subtraction, decrement, this all comes under the arithmetic operation. These are the arithmetic instructions. So that particular arithmetic instruction having some value. So combined value means 0 0. If it is 0 0, if you are 32-bit means this is 8-bit, this is 8-bit, this is 8-bit, this is 8-bit. Totally 32-bit with in the last 32 bit, last 8 bit of 32 is for arithmetic operations. So it's like a do it's, I mean, it's like instruction. If it is 0 0 means it will do the arithmetic operation. If it is 0 1 means it will do the load operation. It will 1 0 means it will do the store operation. Okay. So and then what is cache memory? I already said how Python is converted into assembly. So how Python is converted into assembly? So Python having some interpreter compiler operation, it will converting. So that OS, that compiler will convert the high level code into assembly code, assembly language, and then the computer architecture instruction will it will work based on the instruction like a assembly language. So it will do some arithmetic operations based on the zeros and ones. So this compiler will convert the high level language into machine language. Machine level language is nothing but assembly code, assembly language. Each and every architecture having some own assembly languages. This belongs to the architectural what you are using. So and then so this is the main difference. You can see here this add, so 0 0 means, so already said no, 0 0 is refers to arithmetic operation. Let's see only arithmetic assembly operations only. So this is one instruction. Add is add on our addition operation, R0 R1. So R0 is refers to the this register address. This is on memory, it having some locations. We have to this memory location is called as R0. Register 0 means register 0. This is register 1, register 2, register 3. It will go up to 31. Okay. I am doing the addition operation from R0 and R1. Okay. This this 0 0 is refers to the arithmetic operation. This 0 0 0 1. So this 0 0 is refers to opcode. Opcode is nothing but what you are doing, addition or subtraction, XOR, XNOT, or any subtraction operation. So each and every operation it having some binaries 0 0 0 1 1 0. So for example, addition means 0 0, subtraction means 0 1, decrement means 1 1. So this is opcode operations. This is how that computer architecture will designed, which designed. Okay. And then 0 0, it refers to in the particular R0 register it having value of 0 0, and then in the R1 register it having value of 0 1. So it will do addition operation. So how we can find means this 0 0 is refers to, so we having the 32 bit, we can split into 4, like a 4 bytes. 4 byte means this is first byte, second byte, third byte, fourth byte. This fourth byte is refers to which operation, like a instruction or arithmetic operation. This is refers to ALU. So if it is 0 0 means it is a ALU operation, and then this is a opcode operation. So here the third byte is refers to opcode. Opcode means inside the ALU it having lot of operations: addition, subtraction, multiplication, division, decrement, increment. So kind of there is a lot of operations. To defining that we can use a binaries, 2 bit like a 8 bit binaries 0 0 0 1 1 1. So based on that we can decide addition or subtraction. Okay, and then these are the datas are stored in registers. Okay. So I will show you another I will coming to I think random thoughts. 8 bit data is stored. Yes. So this is like a 8 bit 8 bit ALU. 8 bit means it can, this is a one design for 8 example for 8 bit ALU, 8 bit arithmetic logic unit. It can do add, it can do adder, it can do subtractor, it can do increment, it can do increment. Okay. So here I am doing the binary decode operation. Okay. Here if it is 0 0 means it will choose this. If it is 0 0 1, so if like a here I already said no, this is the opcode, so it can choose the whether what is operation, either addition, either subtraction. So based on these 2 bits, like in the third byte, based on this third byte it can choose whether either 8 bit adder, 8 bit subtractor, 8-bit increment, 8-bit decrement. If it is 0 0 means it will do decrement. If it is 0 1 means it will do increment. If it is 0 1 0 means it will do subtraction. If it is 1 1 means it will do addition operation. Okay, so this is how it will work inside the computer architectural. It is very deep thing. Okay, this is the basic information. This is overview of the operation instruction registers. So first thing is refers to instruction. It is this bit, like this byte is refers to which operation, arithmetic operation or instruction operation. And then if I'm 0 0 means it will choose the arithmetic operation. Okay, here in the coming to the third byte, if it is 0 0 means it will the adder. So based on our logic, so I designed like this only. In real time there is a lot of logic is there, but my logic is based on this third byte. If it is 0 0, add operation. If it is 0 1, add subtract operation. So by using this binary decoder I can control the operations. Okay, and then this is a data registers, data from the registers. 0 1 1 0 is a 0 0 1 0 1 is data are stored in my register. So and then this is look like this only. So after writing the RTL code, I'm converting the RTL code into gates. It will look like this only. So inside the 8-bit increment, it having some logic gates. So that's I'm telling yesterday. We are writing the RTL code, design code. We are test and then we have to test the design code by using the SystemVerilog language. So this is a front end work. After that, we have to convert the Verilog design code into gates. That gates and look like this only, like a XOR gate, OR gate. Inside the 8-bit incrementer, decrementer, subtractor, adder, it having some logic gates. If I show means it will look like some, it will look like a logic circuit itself. So we basically it is a logic gates. Okay, we are controlling the logic gates. In depth, logic gates is not like a logic gates, it is a transistor. So we are controlling the transistor. This is the main thing. So how we can control means by using the instructions which is given by user. Okay, the main thing is ISA will control the hardware. This is a like a overview. This is a topic of, this is a main thing of today's sessions. Instruction having the ISA having instruction, that ISA are inside the computer architecture. It ISA we can control the hardware like this. So and then this is a main operation of the opcode. So opcode means like ALU, it will be having the opcode operand 1, operand 2, and then it will give the result either positive or negative. So this is a main flow of computer architectural. So and then it's time for, so I think you guys are understand. Okay, so yes, all register use 8-bit data by combination of, okay, what is the maximum storage of register? So 30 to 64-bit. Until now, till now current scenario, CPU architectures, computer architecture are using the 64-bit width of our registers. Okay, so how many registers there in 8051? So you need to read the data sheet of the you need to read the architectural for that. So I'm not clear that, so I will tell you tomorrow. So in RISC-V architectural, we totally having the 32 registers. Okay, in the RISC-V architectural, it will differ from architectural. RISC-V architectural are not same, both are different only. In RISC-V we having the 32-bit means 32 register means. In ARM architectural we having the 60 or 50 something. So we have to read the architectural design. So and then we have to read the spec of ISA, lot of things. So can you please provide the notes? That's a, I'm coming to that point. So if you want to notes, if you want to learn these things, you want recording session means you can buy our internship program. So you can convert this masterclass into 1 month internship. Okay, so these are the benefits you will get at the end of the internship, like a 30 days executive recording session, and then you can download all the PPTs, and you can download all the resource code, like a source code. So what I'm doing that session, you can download itself. You can download, and then you will get the exclusive 4 projects, mini project, main project, and then you will get the IETE confirmation internship certificate, and then you will get the 180 days LMS course access. So LMS is a kind of like a interface, and that LMS, we having some, we having stored videos, recorded videos you can watch up to 180 days. And then we are providing weekly task, like a weekly task and assignments. And then we are giving the academic internship report. If you are the studying in student in your colleges, it will be helpful for you. So and then you will get the high valued IETE certificate, internship certificate. So these are the benefits you will get at 1 month of internship. So and then this is a very discounted fee, just 999. So our regular fee is 4000, like a 4999, but our discounted fee is just 999. By using this registration link you will get, okay, and also you will get the link in chat box. Our organization will post the link in chat box. We will, by using this link you can purchase the internship program. So these are the benefits, I already said no. So and then in the once you click the, once you register the link, internship link, you will see this window. You can see this interface. You have to fill this name, email, mobile, WhatsApp number, department, institute, domain. So in here in the domain you have to choose advanced VLSI design and verification. Because of we are providing lot of internship programs, you have to choose advanced VLSI internship, advanced VLSI design and verification, and then you will get the internship program. You can watch the recorded videos. So this is for today, and then after that you will get the internship certificate. I already said no, IETE internship certificates. This is look like this only. This is a sample certificate. It is from the IETE. Okay, these are the benefits you will get the internship, just 999. So if you guys are really interested, you can buy the internship by using this link. Okay, so then this is for today. So if you guys any doubt, you can ask now. So better thoughts, thank you, can you please provide? So you can buy the internship, you will get the notes, Gouda. And then if you guys any doubt, you can ask now. So this is a very basic overview of ISA and RISC-V architectural. Okay. Can I wind up the class? So register size varies from processor to another processor. For example, 8051 is 8-bit microcontroller size. Yeah, register size is vary from architecture, from what are using architecture. There are a lot of architectures in market. ARM architectural, RISC-V, x86. Okay, which will, it will vary from architectural to architectural what you are following. So only RISC-V is only free architectural, and the remaining things ARM architectural, and then ARM architecture, and then x86 are paid. You have to pay for the architecture. So I think, do you guys any doubt? So Institute of Electronics and Telecommunication Engineering, this you can see here. This is IETE, Institute of Electronics and Telecommunication Engineering. It's like a central government, it comes under the central government things. So this is the certificate you will get from the IETE at the end of the internship program. Okay, so I already said stands for IETE. So any doubt from your side, you can ask now, or else I can wind up the class. Yeah, you can get the participation certificate end of the masterclass. If you want to, if you really want to learn this kind of things, you can join the internship program, and you will get the more contents, and you can get the PPTs, downloadables, and lots of more. And then weekly live sessions, you can ask doubts. Okay, thank you guys, thank you for listening. We'll see tomorrow with the topic of digital electronics. This is a very basic thing of a VLS engineer. Thank you guys, thank you for listening.